Hello, my name is Yang Li. I'm the AP teacher here. And today we're going to continue our lesson. First thing first, we're on the 3.2 about the derivative of the function, right? And here, first thing we would like to show you that there are different ways to represent the derivative of the function. Like this one, this is the derivative function. We go by dy dx, also considered derivative function, or a y derivative or y prime, same as a derivative function. And also you have dfx dx, that's considered as a derivative function, okay? So there are different differentiation of the function here, right? Now, and let me just show you something with dy dx. This is the commonly used way. They think, remember before at the very beginning, we introduced the derivative through what? The slope of the secant line and change the slope of the tangent line, right? So right now they do the same things. Here they consider this is data x, this is data y. So this is secant line like this, right? This secant line. And then data y over data x, that's the slope of secant line. But when you data x approaches 0, means this point from here approach to here, means this point go through the curve, go to here until they will get what? Until they will get this tangent line, right? So that's tangent line slope will be dy dx. That's the root of fx, okay? Here we just mentioned something about the different format. That's not big issue on that, all right? Now, let's move on. So we can go to here. We go graphing the derivative, okay? Through graphing derivative, we can get like a deeper understanding about how the relationship between the function of the graph and the derivative function of the graph. And then you can compare, see something there, okay? Let me just show you this one here. Here, we're talking about the original functions, the fx equals square root x. That's what we did from the previous video. The graph will be like this blue one, okay? And then derivative we found already is 1 over 2 square root x. The graph will be this one, right? Now, you can, from here, derivative of fx is a positive everywhere. You see here, x equals to 0.5, derivative is here. You look at the yellow line, okay? So 1 is here, 2 is here like this, always positive. That means what? The graph of original function keeps increasing here, right? You see? And here you can see that if x equals here, the derivative is small. So that's why here the graph increasing at a slower pace. And like here, around here, x is small. And derivative is what? Very big, somewhere here. So that means somewhere here, the slope of tangent line is like this, very steep. And here is flatter. Of course, extreme situation, if x equals 0, the slope, the derivative of the function at x equals 0 will be what? Infinitive, right? So that's why here they have what? Vertical tangent line here. See that? So from here, we can see that derivative of the function is the slope of tangent line of the function. And also show if derivative is positive, means the function is increasing. Okay, this later on, I'm going to use this one to solve word problems. Okay, now here, like this one here, we had this one before. This is a derivative, this is original function, and this is derivative. You can see from here very clearly here. Look at here. This derivative is 0 here. And you have what? Horizontal tangent line here. See that? Slope of tangent line is 0 means horizontal tangent line. And if like this one here, slope, tangent line is like this, slope is negative. So that means what? Derivative is negative, it's lower than 0, lower below the x-axis. And after this point here, the slope is getting what? Bigger and bigger. Tangent line slope is getting bigger and bigger. Even here, it's getting bigger. So from here, you can see that the slope of tangent lines here and here will be, so it's getting steeper and steeper like that. Okay, so from here, you can tell that derivative of the function at that point will be the slope of tangent line. And if the slope derivative is positive, means the function is increasing. And if derivative is negative, the function is decreasing. And if derivative equals 0, that's the time you're gonna have a horizontal tangent line. That's a minimum, either minimum or maximum occurs. Okay, that's the one we're gonna discuss later on. Now look at it here. They ask you sketch f derivative. They gave you the f right now. Okay, let's look at what they gave us the f. Okay, based on this graph, they ask us to graph what? Sketch the derivative using the given function here. Okay, now let's look at this function here. We can see that we still use the same concept we just discussed. Here, this point here, horizontal tangent. Here, horizontal tangent. Means we know the derivative here to be 0 here. Derivative here, function should be 0 here. And here is decreasing. You see that? Means the derivative should be lower than 0. Means what? Lower than the x-axis. Of course, here's just a general sketch. So we may just sketch like this, right? Go to here. And after that, this is a positive, 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 right? So that means this one is getting above the x-axis. But they should come back here. Because here the derivative slope of tangent line is horizontal. So it means what? Slope is 0 here. Derivative is 0, so they go back here. And after that, this is a negative, negative. So that's why this one go down like this. Of course, this is not exact graph, but just a general sketch reflecting the properties between the derivative and the original function, okay? So you can see what they got to give you here like this, huh? Right? They gave you the graph like this, but make sure you understand this concept here, okay? Yeah, so that means from here we can see that if you use the, if you're given the function graph, you can make a general sketch the derivative of the function, okay? As what they did before, every time after they show you some questions, examples, they ask you do something, practice by yourself. Right now, you may pause this video and do it by yourself. And now I'm going to explain to this part for you. And then you can watch it after you practice by yourself, okay? Now, I'm going to do is this here. I'm going to make a XY coordinates first, okay? So I'm going to do is draw a XY plan first. I'm going to draw XY plan here like this. So we go, this is the y-axis and this is the x-axis, okay? This is the x, this is the y. And then we know this graph is x equals -4. For example, here is -4. X equals 0, y equals -4, that's here, huh? Right? X equals 1, what happens? X equals 1, 1 squared is 1 minus 4 is -3. So 1, 2, 3, somewhere here. Of course, -1 is same. On this side, same. Right? If you go 2 squared is 4. 4 minus 4 is 0, that's here. -2, same, 0 here. So general sketch the graph should be like this, okay? It's not that nice, but it's for the illustrative purpose, like this one. This is the original function fx. Now we're going to find out what derivatives, right? How do you find the derivatives function? We go like this here. We know here is 0. So because here, horizontal tangent line, derivative of at the x equals 0, we know f derivative of the 0 equals to 0, right? So if you have that, so you can say passing through this point, okay? And then before the x equals 0 here, this is going decreasing. So that means the graph is what? The graph is below the x-axis. And after that, this derivative, the slope is positive here, see? Right? Tangent slope is positive. So this one should be going to like this. Of course, here I'm not drawing as what the curve, like drawing straight line. The reason for that is if you do find the derivative of the x will be equal to x. So I knew this one should be a linear function, so a straight line. Okay, so I'm going to continue with next video. We'll cover the derivatives and the continuity. That's a very important concept. Sometimes students are a little bit confused on that, but we're going to cover that one. Okay, so if you have any questions, please email me so I can help you with your question. Okay, thank you. Bye-bye.